All right, adding and subtracting rational expressions. So reminder, this is like adding and subtracting fractions. So when you add and subtract fractions, you have to have a common denominator. So you must also have a common denominator when you're adding and subtracting fractions. So we're going to look at just the first couple examples today, and we're actually going to look at the ones that have a common denominator. So the part today will be a little bit easier, and then tomorrow we'll look at unlike denominators and how we can put those together. So here we have 2x over x to the fourth plus 4x over x to the fourth, and we want to add these two fractions together, these two rational expressions. Now one of the things is that when you're adding them, when you're all done, you have to make sure that you can't simplify your answer. And sometimes you might be able to simplify it even before you add it. You have to just take a good close look at the problem and figure it out from there. So these two have a common denominator, so I can go ahead and add them together. And we'll get 6x in the numerator and x to the fourth in the denominator. So make sure you don't actually add the denominators, right? When I have a common denominator, that means it stays as the denominator. So in other words, we could write this as 2x plus 4x over x to the fourth, which would simplify to 6x over x to the fourth. Am I done? No, because these both have an x in them, so I can simplify that to 6 over x cubed. Okay, let's look at another example here. So these two have a common denominator. I'm adding them together so I could write it all over my common denominator. So just remember, do not actually add these denominators together. It's just the common denominator. What's that? 2m of the 4 from the denominator. Okay. All right, so now I'll simplify it. So we get m squared plus 5m plus 4 over m plus 4. Now the question is can I simplify it further? And since we have a quadratic here, then we need to see if we can factor it, because it's a possibility that I'll have a common factor with the numerator and my m plus 4. So we need to factor that to see. And if I factor the numerator, I get m plus 4 and m plus 1. So I do have a common factor with the numerator and denominator, so I can simplify that. So m plus 4 goes into itself one time. So then we're left with m plus 1. Okay, so when we have a common denominator, when we're adding, it's not too difficult. You just need to make sure if you do have a quadratic or something that you can factor when you're done, that you factor it to make and check to see if you can simplify further. But having a common denominator to begin with makes things easier. Subtracting. Now, when we're doing subtracting, it adds a little bit of change to it that we have to be careful because of the subtraction with our problem. So first thing, we'll write the whole thing over our common denominator, and then we'll work from there. So we have our common denominator in this case is y squared plus 4y minus 12. So in the numerator we have 6y minus 6 minus the quantity y plus 4. Now I'm putting the minus sign and the parentheses there to remind me that I'm subtracting that whole thing, and that when we subtract a polynomial, what actually happens. Okay. Because we're distributing the negative sign, then everything's going to switch signs. So this becomes 6y minus 6 minus y minus 4 over y squared plus 4y minus 12. So I have to make sure that I distribute this minus sign or this negative sign so that it changes all the signs in this part of the expression. So when I simplify the numerator, we have 5y minus 10 over y squared plus 4y minus 12. So when I get to that point there, then I need to see if it's possible that I could factor and have a common factor that I could simplify. Well, let's look at the numerator. Do they have anything in common? Okay, they have a 5. So I take out the 5 and I have y minus 2. So in the denominator, I'm hoping I have a y minus 2 then, right? So I'll be able to cancel those out. So we factor denominator. What are the factors of negative 12 that when I combine them, I get positive 4? Okay. Plus 6 and minus 2. All right, so y plus 6 and y minus 2. And so we do have a common factor of y minus 2. So this is equal to 5 over y plus 6. All right, so you guys do letter A. So if we have a common denominator, it's pretty easy to do it. You just need to make sure of when it's subtracting that you put it in parentheses so that you remember to distribute the negative sign. Now, so we're going to look at least common multiples, because when it comes to problems that do not have a common denominator, the least common multiple of those denominators, or the least common denominator, is what we need to find. And so what we're going to do is we're going to look at finding the least common multiple first. And then tomorrow, we'll go ahead and put that together with finding fractions, or adding and subtracting with uncommon denominators. So, the rules for finding the least common multiple. We want to write the prime factorization of all the expressions. What do we mean by prime factorization? That means we're just going to list all the prime factors, all the prime numbers, and take all the variables and pull them apart also. And then to find our answer then, we're going to use each factor the greatest number of times it appears. So they showed a couple examples here. 6x squared. Prime factors are 2 and 3, and then x times x. 8x. If I write prime factorization, I have 2 times 2 times 2, and x. So we circle, or we're going to include our answer in the greatest number of each of those prime factors. So I have a 2 here with 6x squared, but 3 2's with the 8x. So I'm going to choose the 3 2's. There's only one 3, so I need that. I have 2 x's in the first one and 1 x in the second one, so I'm going to select those 2 x's. So it would be 24x squared. So another way to think of that is this. All right, as far as, let's talk about the numbers first of all. We have, when we're talking about least common multiple, all right, we're talking about multiples, not greatest common factor. Right? And that's something that people get mixed up. Right? Multiples of 6, 6, 12, 18, 24, 30, 36, and so on, right? Those are the multiples of 6. The multiples of 8 are 8, 16, 24, 32, 40, and so on. So we want the least common multiple with 6 and 8. So the smallest one is 24. So what did we have? We had the least common multiple of 6 and 8 was 24. And then with variables, you just pick the one with the largest degree. Over here with 5x plus 15 and x squared minus 9. The 5x plus 15, they factored out the 5. X squared minus 9, we factor that, we get x plus 3 and x minus 3. Right? So for our least common multiple, we write down each factor. I have a factor of 5, factor of x plus 3, factor of x minus 3. They all only happen one time is the largest amount of each one of them. So then my least common multiple would be all of them, just those multiplied together. Right. So let's try a couple examples here. Right. 12x squared y and 9xy cubed. Now, sometimes people find it hard to do the prime factorizations of the numbers. Okay, I'm okay with that. Okay. Let's just think about 9 and 12. What's the smallest number they both go into? Right. So that means I could list the multiples of 9 and 12. So what's the smallest one there that they both go into? 36, okay? So my least common multiple here would be 36. What's the largest exponent for the x's? Okay, x squared. And the largest exponent for the y? Y cubed. And that would be my least common multiple. So if I listed them, this is 2 times 2 times 3 is 12. X times x times y. Down here we get 3 times 3 is 9. We have a single x, and we have y 3 times. So I choose the largest of each factor. So we have 2 2's. Okay. I have a 3 here, but I have 2 3's there, so I'm going to need them. Right. And 4 times 9 is 36. I have 2 x's here and 1 x here, so I'm going to choose these 2 x's. I have a y here and 3 y's there, so I'm going to choose those 3 y's. So 4 times 9 is 36, x squared, y cubed. So you can think of it as, take the two of the constants, right? What's the smallest number they go into? And then when we look at the variables, I have a variable of x and a variable of y, and just choose the highest power of that one. Okay? So we got the x squared and the y cubed. Okay? Letter B. So we're going to write these in factored form. We have c plus 5 and c plus 3 for c squared plus 8c plus 15. And we have 3 times what? Okay. C plus 3. And if they're both c plus 3, then it's c plus 3 squared, right? You all right with that, Shelby? Or you want to see it? Okay. So this is 3 times c squared plus 6c plus 9, right? Which when I factor c squared plus 6c plus 9, I get c plus 3 times c plus 3. So to get my answer, how many different factors do I have? Different ones. I have 3 different factors, right? I have c plus 5, c plus 3, they both have a c plus 3, right? Okay. And then 3. So to get my least common multiple, I list all the factors here. And then look at the power of each one. Okay? The power of the 3 is 1. Power of c plus 5 is 1. Okay? Now, since they both have c plus 3, I'm going to choose the largest one of those, which would be squared. And that would be my answer. So to find the least common multiple, we list the factors. My least common multiple then would be, I put all the factors down, and whatever the greatest power is for each of those factors, That's what's included in my answer then. I just multiply those things together. Let's look at one more. Let's look at 3b here on the check it out. The first one has x minus 6 and x plus 2. And then I've got x minus 6 and x plus 5. So to find the least common multiple, we write down all of the different factors. Okay? How many different factors are there? There's 3 of them. X minus 6, x plus 2, and x plus 5. Now they both have x minus 6, but those both are only to the first power. There's only one of them, so I only list one of them in my answer. I don't put this as squared. I'm only going to write it as to the first power. Right? Because it's not squared in either one of them. It's only to the first power. So you list all the different factors and then take the greatest power of each of those factors then.